Dear students, once again I am Mr. Vishal Shah, Assistant Professor, Krishna Institute of Pharmacy, Karad. Welcome you all to this second video of our third chapter, that is the aromatic acids. In previous video, we have seen introductory part related to the aromatic acids, as well as we have seen how to carry out the nomenclature of the other derivatives of aromatic acids by considering the benzoic acid as a parent compound. We have started with the methods used for the preparation of the aromatic acids. In that, we have seen three different methods that are used for the preparation of the aromatic acids. First method was industrial method. Second method that we have seen was the oxidation of the alkyl benzenes, and third method that we have seen is from the Grignard's reagent. Now today we are going to see other methods that are used for the preparation of the aromatic acids. Now fourth method that is used for the preparation of aromatic acids is from nitriles. Now this is also one of the important method, because nitriles, they are also known as the cyanides. These cyanides, when undergo the acid hydrolysis, they are converted into the carboxylic acid functional group. So this is also one of the common method where the cyanides, when undergo the hydrolysis, they are converted into the acids. For example, here you can see phenyl cyanide, which is also known as the benzonitrile. Cyanide and nitrile, they are nothing but the same functional groups, where the phenyl cyanide on hydrolysis, it will be converted into the benzoic acid. Whenever cyanide functional group is used, the cyanide functional group undergo the hydrolysis and it will be converted into the carboxylic acid functional group. So depending upon the which cyanide that we are going to use, the product that is formed, it will be a different. This is quite simple method, that is the from nitriles. Then next method that is used for the preparation of the aromatic acids, that is the benzoic acid, is from hydrolysis of benzo trichloride. Now when benzo trichloride is hydrolyzed in the presence of the aqueous alkali, say for example sodium hydroxide, it will be converted into the benzoic acid. Again here also we are going to carry out the hydrolysis of benzo trichloride. Now this required quantity of benzo trichloride is obtained by chlorination of toluene in presence of the ultraviolet radiation. Now whatever the amount of benzo trichloride that is used in this reaction, that we have to prepare, and that is to be prepared from the chlorination of toluene in presence of the ultraviolet radiation. Now here you can see. Now this is the structure of the toluene. Now you can remember that here we are going to use the ultraviolet radiation, because normally if we perform the chlorination, the chlorine groups will be substituted at the aromatic ring, that is the benzene ring. But if we perform this chlorination in presence of the ultraviolet radiation, these chlorine groups are substituted to the alkyl group instead of substituting at it the benzene ring. That's why it's important to perform this chlorination under the presence of the ultraviolet radiation. So toluene, when undergo the chlorination in presence of the ultraviolet radiation, it will be converted to the benzo trichloride, and this is the compound from which we are going to carry out the synthesis of the benzoic acid, where this benzo trichloride, when undergo the hydrolysis in presence of the aqueous alkali, that is the sodium hydroxide. Here we can use potassium hydroxide also, which leads into the formation of the sodium benzoate. That sodium benzoate is known as the sodium salt of the benzoic acid, and this sodium salt, as it is water soluble, which on hydrolysis, that is in presence of the acid, it will be converted into the benzoic acid. If strong acid is used, this sodium will combine with the strong acid and the benzoic acid will be free from the sodium salt. In this way, this second method is used for the preparation of the benzoic acid. This is about the fifth method that is used for the preparation of the benzoic acid, that is the benzo trichloride. Further, sixth method that is used for the preparation of the benzoic acid is again from the benzyl alcohol. This is the aromatic alcohol which on refluxing with the potassium permanganate, that is the oxidation, it will be converted into the benzoic acid. Benzyl alcohol is actually not an aromatic acid, it is a side chain alcohol. Now the mixture is hot filtered to remove the manganese dioxide and then allowed to cool of the afforded benzoic acid. This is the reaction. As I said, this is not aromatic alcohol. Here this carboxylic acid group, as it is connected to the carbon, this is known as the aliphatic alcohol. So benzyl, this group, that is the C6H5 and CH2, this group is known as the benzyl, and benzyl alcohol on oxidation with the alkaline potassium permanganate. Now here one good thing is that we can use any type of potassium permanganate. Either we can use the acidic potassium permanganate, also we can use the alkaline potassium permanganate. Generally here the KMnO4 is converted into the manganese dioxide, and we have to remove this manganese dioxide by using the different sulfide. Means we have to convert manganese dioxide into the manganese sulfide so that it will be solubilized and it will be removed from your benzoic acid. Actually this method is quite difficult, where you will require so much amount of time. Also it is difficult to remove the manganese dioxide because they are present as impurities. Otherwise we are not able to carry out the separation of the benzoic acid. And that's why benzyl alcohol on oxidation with either potassium permanganate or other oxidizing agents can be converted into the benzoic acid. So this is about the sixth method that is used for the preparation of the carboxylic acid, that is the from benzyl alcohol. Then last method that is used for the preparation of the benzoic acid is from the benzyl chloride. Now in previous method we have used benzyl alcohol. Here instead of alcohol we are going to use the chloride. That is the only difference. Now benzoic acid can be prepared by oxidation of benzyl chloride in presence of the alkaline potassium permanganate. Means this method is also quite similar to earlier, only we have to use benzyl chloride instead of the benzyl alcohol. You can make correction over here. Instead of this OH you have to write down the Cl, because here we are going to use the benzyl chloride. So this is the mistake over here. So benzyl chloride on alkaline oxidation with the potassium permanganate, it will be converted into the benzoic acid. Means this method is also quite similar to the preparation from the benzyl alcohol. Now in previous method we have not used alkaline potassium permanganate. In that case also we can use, but here we have to use the alkaline potassium permanganate so that the benzyl chloride can be easily converted into the benzoic acid. So these are the various methods that are used for the preparation of the aromatic acids. Namely, first method that we have seen is industrial, where we are going to carry out the oxidation of the toluene with the help of the cobalt or manganese to the benzoic acid. In second method, alkyl benzenes that we have used, these alkyl benzenes when undergo the oxidation with alkaline potassium permanganate, they will be converted into the benzoic acid. Then third method, where we have seen we are going to use the Grignard's reagent. So phenyl magnesium bromides can be easily converted into the carboxylic acids. After that, next method that we have seen is from hydrolysis of nitriles, where nitriles undergo the hydrolysis, that is the nitriles are also known as the cyanides. These cyanides when undergo the hydrolysis, that is the acidic hydrolysis, they are converted into the benzoic acid. Also we have seen how to carry out the preparation of benzoic acid from benzyl alcohol as well as the benzyl chloride, where also we are going to use the potassium permanganate to carry out the oxidation of benzyl alcohol as well as the benzyl chloride, which leads into the formation of the benzoic acid. So these are the various methods that are used for the preparation of the benzoic acid. Next point that we are going to discuss is about the chemical properties that are shown by the benzoic acid. So let's start with the chemical properties of aromatic acids. First chemical property that is shown by the aromatic acid, that is the benzoic acid, is salt formation. Now broadly, like other compounds also, we can divide chemical properties of aromatic acids into two parts. One, the chemical properties that are shown due to the presence of carboxylic acid functional group, and the second, the chemical properties that are shown due to the presence of the your benzene ring, that is the chemical properties that are shown by the aromatic compound, like electrophilic substitution reaction. Because aliphatic carboxylic acids does not show electrophilic substitution reaction, while aromatic acid show the electrophilic substitution reaction due to the presence of the benzene ring. So that's why this is the difference between the aromatic acids as well as the aliphatic acid. So first property that is shown by the benzoic acid is due to the presence of the carboxylic acid functional group, that is the salt formation. Now benzoic acid, when reacts with different alkali, say for example sodium hydroxide, sodium carbonate, potassium hydroxide, this leads into the formation of the sodium benzoate. This sodium benzoate is known as the sodium salt of the benzoic acid. If we use potassium hydroxide, there will be formation of the potassium benzoate will takes place. So depending upon the which alkali that we are going to use, here there will be formation of the different product is obtained. Say for example benzoic acid, on reaction with the NaOH, that is the sodium hydroxide, it will be converted into the sodium benzoate, which also leads into the formation of the water. And when benzoic acid on a treatment with the sodium bicarbonate or sodium carbonate, here suppose we have used the sodium bicarbonate NaCO3, which also leads into the formation of the sodium benzoate, and also it leads into the formation of the or evolution of carbon dioxide. So this reaction is used as a identification test for the all aromatic carboxylic acids, because benzoic acid or the carboxylic acids, when they react with sodium bicarbonate, there will be evolution or the effervescence of carbon dioxide is observed. So this is the test which will show you or identify whether your compound is consisting of carboxylic acids or not. Then second chemical property that is shown by the aromatic acids is ester formation. Esters, as we know, they are nothing but the RCOOR. These functional groups are prepared by combining alcohols with the aromatic acids. So when alcohols are reacted with benzoic acid in presence of the mineral acids, say for example sulfuric acid, which is used as a catalyst, it will be converted into the ethyl benzoate. Let's see this reaction. Here you can see benzoic acid on reaction with the ethyl alcohol. In presence of the sulfuric acid, it will be converted into the ethyl benzoate. So in this way, we can carry out the preparation of the ester functional group. You can see over here there is a presence of RCOOR. So these functional groups are known as the ester. Similarly, if esters undergo the hydrolysis, they will be converted into the benzoic acid and the alcohol. So esters are formed by the combination of the carboxylic acids and the alcohol. Remember, these two properties are due to the presence of the carboxylic acid functional group in our structure. So these are the various methods of preparation used for the benzoic acid as well as the few chemical properties. Remaining chemical properties we will see in the next lecture. Thank you. If you like this channel, you can share and subscribe my channel. Thank you. Thank you very much.